everybody, welcome to the WX Kevin YouTube channel. My name is Kevin. Today I would like to kick off my YouTube channel by discussing a weather event from this year 2025. This severe weather event turned out to be one of the most impactful events of 2025 that spawned one of the most powerful and deadly tornadoes of the entire year in a location that might surprise you a little. On May 16, 2025, a tornado outbreak would occur that impacted areas from Arkansas and Missouri all the way to the northeast. The deadliest tornado of the outbreak was an EF4 tornado in south central Kentucky. On the evening of May 16th, a tornado touched down in eastern Russell County and would travel 60 miles through Pulaski and Laurel Counties, impacting the cities of Somerset and London, Kentucky. The tornado would reach a maximum width of nearly 1 mile wide and cause fatalities, damage, and destruction in Russell, Pulaski, and Laurel counties. Today we'll be discussing the meteorological setup and the impacts of this tornado outbreak. This video goes out to all weather enthusiasts, but also to those impacted by the outbreak, specifically those in Ely, Somerset, and London, as well as any other communities that were impacted like Mount Victory. I hope you enjoy this video. Please leave a like and subscribe, as this is the first of many videos I have planned for the channel. I made a short video on May 16th and put info in there that this area of Kentucky are not strangers to tornadoes. Between the 1974 super outbreak and 2025, Pulaski and Laurel counties alone had experienced 30 tornadoes. Most of these were weak tornadoes. 3 of them reached the significant threshold, which was EF4 or higher, which had winds of 111 miles per hour or stronger. A quick recap of the major events from May 16th tornado outbreak. It was definitely a prolific event with 57 tornado reports, 843 severe wind reports, and 383 severe hail reports. A report does not mean confirmed, but still it was a powerful setup. Preliminarily, at least 31 tornadoes have been confirmed for May 16th. This includes 1 tornado rated as EF unknown because it didn't hit anything, 5 EF0s, 13 EF1s, 7 EF2s, 3 EF3s, and 2 EF4s. 170 people were injured and 26 lost their lives. Now, some sources combine May 15th and 16th together. In that case, there are preliminarily a number of 61 confirmed tornadoes. To quickly cover some notable events from the day, the first big story was a tornado that struck downtown St. Louis at EF3 intensity. The tornado grew up to 1 mile wide and it caused 38 injuries and 5 deaths. This one tornado caused a whopping $1.6 billion in damages. The tornado that struck around the Blodgett, Missouri area was another noteworthy event. As we'll cover throughout the video, this was perhaps the first tornado that spawned from the supercell that would later wind up over Russell, Pulaski, and Laurel counties. The first tornado was 200 yards wide, injured 10, and killed 2. The most powerful tornado of the event occurred in Marion, Illinois. Here, an EF4 tornado with max winds of 190 miles per hour injured 7, and the tornado grew to a half-mile wide. This was a high-end EF4, just 11 miles per hour below the strongest category of EF5. This storm system was widespread and caused havoc even as far to the northeast as Baltimore, Maryland. The tornado that hit Baltimore was a weaker tornado, but it was wild that 2 metropolitan areas were hit by tornadoes in the same day, St. Louis and Baltimore. And our focus will be on one of the outbreak's final tornadoes, the Ely, Somerset, and London EF4. This was the second most powerful tornado of the event, but by far the deadliest, with 19 fatalities. This was a violent, long-track tornado, and it was a nocturnal tornado, and it traveled 60 miles and reached nearly a mile wide. According to the staff at the National Weather Service in Jackson, Kentucky, this is one of the strongest tornadoes to ever impact the NWS Jackson, Kentucky area of responsibility, and sadly also the deadliest. Alright, so to kick things off, I want to look at the previous day's setup for May 15th to get an understanding of the synoptic environment that led to such an impressive outbreak. As I'd mentioned previously, both May 15th and 16th are sometimes lumped together to discuss this outbreak. I view them personally as separate events. On this day, areas in and around Michigan were under an enhanced risk for severe weather by the Storm Prediction Center, with a 10% hatched area denoting the chance for significant tornadoes. Around that was a 5% risk area that did cover some of Kentucky and areas that would be affected by the next day's storms. So the best way to get an idea of the synoptic environment is to look at something called the 500 millibar upper air analysis, which looks at winds at 18,000 feet above our heads. So as we look at the 500 millibar upper air maps, let me quickly explain what we're looking at. So the black lines running across the map are called height contours, and these denote what the air pressure is at that specific height in the atmosphere. Then these little lines that you see throughout the entire map are called wind barbs. This denotes what direction wind is blowing at this height, as well as how fast the wind is blowing. The areas in blue are areas of maximized winds and are an area where we focus on looking at wind shear. So this first map I have for you is for May 15th at 11Z, which translates to 6 a.m. Central Daylight Time. So a couple things that I noticed right away with the map. First thing, if you look at the area over the northwestern part of the United States where the black lines make a U, that's a feature in the weather world called a trough. And this is important because through complicated processes like Lee cyclogenesis, this is what helps to create maximized areas of wind shear, which is one of the ingredients for severe weather. Now, something else about this trough that's noteworthy is how it's oriented. So if an open part of the U is facing more of a northwest direction, that's considered a negatively tilted trough. And that's a buzzword in the weather world for significant severe weather. This is because not only is wind shear maximized in this environment, but it's able to more easily pull warm, moist air from the Gulf, and on the backside of the trough is cooler and drier air. Typically, when you get warm and cold air mixing, you get severe weather. Now, at the bottom of the U is typically considered the axis of the trough, and this is typically where you find some sort of boundary like a cold front. This provides a lifting mechanism for any air parcels that are available in the environment to be booted up into the upper atmosphere. And as these warm, moist air parcels cool and condense, they will form clouds that, in the right environment, can foster explosive storm growth. One other note for this discussion is back to the wind barbs. So, just to teach you a little bit about how to read these, let's look at the Texas Panhandle and Oklahoma Panhandle. On the side that looks like it has a little flag and a bar, that tells me that there's 60 mile per hour winds coming from the west-southwest and going toward east-northeast. But these maps also cheat for you a little bit, so if you look at Kansas, you can see a blue circle with a 70 in it, and that denotes 70 knots of wind shear. The reason I point this out is because you can follow the wind barbs and see where the air is coming from. So when you look at the next image, which is at 19Z or 1 p.m. Central Time, you can see that the jet stream is maximized to 90 knots. There's something else interesting to look at when you look at Kentucky. See how the height contours, the black long lines, form a more upside down U rather than what we discussed with the trough? The opposite of a trough is called a ridge, and ridges are typically not conducive to severe weather. Ridges usually are accompanied with a high pressure system, and it looks like there's one over New Orleans area as of 19Z. Now over the Dakotas, that's a low pressure system which usually accompanies a trough. When the Storm Prediction Center was giving the forecast for May 15th for the Kentucky area, I was not incredibly worried because if you look at the wind barbs and how they're oriented, they're coming from kind of the Mexico desert southwest area, which means this is carrying more warm, dry air rather than warm, moist air. And this creates something called a temperature inversion. And you probably have heard people mention a cap. This is what kind of helps to inhibit storm growth. So a strong enough cap will inhibit storm initiation. And we did have a few storms on the 15th, but they really didn't do a whole lot. However, for areas in and around Michigan, there was significant severe weather that took place. With the maximized wind shear of 90 knots, it provided an ample environment for severe weather. As we'll see, though, this did set the stage for some severe weather to take place late Friday morning into Friday afternoon. This was one of the questions that meteorologists and people like me, weather nerds, had whenever they were looking at the setup for May 16th. Would these morning rounds of storms or any other convection that occurred, would that kind of dampen the impact of the evening storms? So before we move on, I want to give you a very quick crash course on severe weather. Last year, when I was preparing my Be Weather Ready material, I watched a YouTube video from a meteorologist named Jacob Morse. He's a meteorologist for a station up in North Dakota, and I loved his way of remembering the ingredients for severe weather. So let me introduce you to the acronym SLIM. S stands for wind shear. Shear is wind blowing higher in the sky but at a more sustained or steady rate. Have you ever heard of the jet stream? This is winds that are blowing at 30,000 to 40,000 feet, but it greatly affects the weather we experience down on the ground. We'll be looking at wind shear at lower levels as well. And these are two types of wind shear that I have before you: speed shear and directional shear. Speed shear matters because I'm going to simplify this a little bit. So say you have winds that are 3 miles up and they're blowing at 100 knots. That's about 115 miles per hour. And then you have winds that are 1 mile up blowing at 50 knots. This actually creates horizontal spin. Directional shear is when winds are at different heights or blowing in different directions. So either type of shear can be present or both can be present. This is important because wind shear can affect a thunderstorm's updraft, and it can help to sustain a thunderstorm rather than choke it off. Storms that pop up and then fade in and out in about an hour do so because these storms essentially collapse in on themselves. But wind shear helps to sustain storms. L stands for lift. Lift occurs from a boundary. A boundary can be a front, like a cold front or a warm front, or a more regional boundary called a short wave. It could also be a moisture boundary called a dry line, or topographical features like mountains, the Rocky Mountains or Appalachian Mountains can provide lift as well. There's even localized boundaries from rain-cooled air that spreads out from a storm called an outflow boundary, and they can also initiate storms. Something to help punt the air parcel upward, especially on a large scale, and that creates something called forcing for ascent. I stands for instability. If lift helps to push warm air upward, instability tells us how easily that warm air can rise, and if it continues to rise when it's lifted. One of the most common ways that this is measured is through convective available potential energy, or CAPE. It's measured in joules per kilogram because it's a measure of how much energy is released for every kilogram of air. 1,500 joules per kilogram is generally the threshold for tornado potential. And M stands for moisture. Storms don't happen without moisture being present because moisture is how clouds form. Moisture and temperature have an important relationship because if, for example, the dew point is 70 degrees Fahrenheit and the temperature is 70 degrees Fahrenheit, that means the relative humidity is 100%, and that generally means that there's clouds forming. So whenever you're driving to work of a morning and it's really foggy, that's because the air temperature and the moisture content of the air are the same. There are other factors that I'll discuss as we get back to the May 16th case study as well. So the Storm Prediction Center issued a Day 5 severe weather outlook with a 15% risk over western Kentucky, western Tennessee, northeastern Arkansas, and southeastern Missouri. And on the Day 4 outlook, the Storm Prediction Center moved the risk to cover most of Kentucky except for the extreme eastern part of the state. There wasn't much refinement when it came to the Day 3 categorical outlook, and the main question was what type of storm mode would we have for the setup? Would we have a line of storms with a damaging wind threat and maybe a spin-up tornado threat? Or would we have discrete supercells for an all-hazards threat? Now, even 3 days out, it was apparent that this would be an environment very conducive to significant severe weather. These are all parameters that we'll discuss more in detail as we go, but items that catch my eye are the mixed layer CAPE values around 3,000 joules per kilogram, an effective bulk shear of 40 to 50 knots. And in that outlook, they also discussed the morning round of storms, how it wasn't very clear on how these would impact the environment for the evening round of storms. But given the kinematic environment, it was apparent that we were in for a stronger than average storm event. Now we move to the Storm Prediction Center's first Day 2 categorical outlook, which had placed practically all of Kentucky in an enhanced risk, which is level 3 out of 5 for severe weather. They had already denoted a 10% hatch tornado outlook area over western Kentucky as well as Missouri, Illinois, and Indiana. That means that not only is there a 10% chance of a tornado occurring within 25 miles of any given point in the yellow circled area, but there's a chance of a significant tornado of EF4 or greater. And here in the discussion was the first indication of an environment that might support a window of opportunity for sustained or long-lived supercells with the potential to produce large to giant hail and a couple of strong tornadoes. And in addition, behind any sustained supercells would form a line of storms. So we were already looking at a mixed mode of severe weather with all hazards being possible. This was already looking to be a high impact event. Then we get to the second Day 2 outlook that the Storm Prediction Center issued, and we would see an upgrade to moderate risk, or a level 4 out of 5, that encompassed western to central Kentucky, Missouri, Illinois, and Indiana. The enhanced risk was expanded on as well to cover the rest of Kentucky, as well as the majority of Tennessee, Arkansas, and even stretching into Ohio and West Virginia. In this outlook, the 10% risk for significant tornadoes was moved to cover central Kentucky, with the rest of the state being included in a 5% risk for tornadoes. The entire state of Kentucky was in at least a 30% risk for significant severe winds, denoted by the hatched region, but western Kentucky was actually added to a 45%, which you don't see very often. The same areas would also be included in a 30% risk for significant hail. The wording from the Storm Prediction Center was very concerning, as they stated that a regional outbreak of severe thunderstorms was likely across parts of the middle Mississippi and Ohio valleys on Friday afternoon into Friday night. So what the Storm Prediction Center was seeing was that after the morning round of storms, there would be rapid recovery to allow for significant destabilization of the atmosphere, and that the combination of higher wind shear pulling the warm, moist Gulf air would lead to this rapid destabilization, and any breaks in the clouds during this time would only add insult to injury. So now we get to the Day 1 outlook, which is where we'll set the stage for the rest of this discussion. The moderate risk was kept for a level 4 out of 5 and expanded slightly eastward. All the rest of Kentucky was kept in an enhanced risk. The Storm Prediction Center added a 15% hatched area over western and central Kentucky for the chance of significant tornadoes, and expanded the 10% hatched risk eastward, but not encompassing all of Kentucky. It did, however, include Somerset and London. The 45% risk for significant wind damage was kept pretty much in the same areas as before, but all of Kentucky was in at least a 30% hatched area for significant wind damage. This was what was mainly driving the moderate risk, but the tornado threat was very present too. Practically, the entire state was in a 30% risk for significant hail, with extreme western Kentucky being added to a 45% risk for significant hail damage as well. So in the discussion for the Day 1 outlook at 20Z, the Storm Prediction Center discussed the fact that a developing cold pool from the Tennessee and Kentucky area was present in the warm sector. The hope was that this would limit the chance for discrete supercells prior to the line of storms coming through, but unfortunately that would not be the case, as now the risk for a long-track violent tornado was a very real possibility. It looked like the greatest ingredients would be in the western Kentucky area, but as we know, that wouldn't exactly be the case. The storm event from before was still taking place by 0Z, or 8 p.m. Eastern Time, but wind shear was increasing over Kentucky at 6Z, or 2 a.m., and by 12Z, or 8 a.m. Eastern Time, a 70-knot wind shear maximum was occurring over Bowling Green, and the ridge from before had moved eastward. So now Kentucky was positioned in the axis of the trough, where in this instance, a warm front would advect to the northeast, which would carry leftover convection from the night before. In addition, something else to learn about the 500 millibar chart and the height contours we discussed earlier are to look for areas where the height contours move away from each other. This is known as defluence. This is the area known as the exit region of the trough, and air pressure at this height decreases, a phenomenon known as divergence. Air that is underneath this region will move upward to compensate for this lowered air pressure. A good example of another map that shows this is the 300 millibar height. So these pink circles represent divergence, which is where the winds spread apart up at the top layer of the atmosphere. And at the 300 millibar level, which is about 30,000 feet in the air, this shows that storms have the ability to grow very tall. If we look a little bit lower in the atmosphere at the 700 millibar upper air map, this is about 10,000 feet in the air, and this is where we look for something called short waves. Shortwaves are deviations or kinks in the airflow. This helps to introduce two things, lift and vorticity or spin. Now, spin doesn't always mean tornadoes, but it can mean the formation of a stronger and more sustained updraft to produce more of a large hail threat and, of course, a tornado threat as well. So 700 millibars at 12Z. Remember, this is at 8 a.m., and the first round of storms didn't come through until a little bit later. It's hard to pick it out, but I do see a slight kink in the flow near the Paducah area. I've drawn areas where I see these shortwaves. I can also see another one over western Arkansas and Missouri. Pay attention to that for later. Something very intriguing will be happening later. As we look at the 850 millibar map, or 5,000 feet up in the sky, shortwave is also present. The 850 millibar map is best used for analyzing lower level jet wind shear at around where the base of the storms would be. Okay, so the morning and early afternoon round of storms would come through Kentucky, and the question would be, of course, would this round of storms limit what the evening round of the storms could do? Let's just take a look at some surface data to see what actually happened. So looking at the south central Kentucky area at 16Z, this is about noon Eastern. Convection was about to be ongoing in the area, and you can see what the morning round of storms would do to the atmosphere. So just looking over the London area, 75 degree temperature and around 69 to 72 degree humidity. 2 hours later at 18Z, the symbol that looks like an R denotes where a thunderstorm is ongoing. At this point, it already zapped the atmosphere over this area. You see the 63 degree temperature and 62 degree humidity, so basically the atmospheric ingredients were used up. But watch what happens when we move it forward 5 hours. Rapid recovery of the atmosphere with mid to upper 70s temperatures and low 70s dew points by 23Z, which was about 7 p.m. Alright, so thank you for hanging in there with me so far. This is where things are really going to get interesting. We're going to take a look at another 850 millibar map, and this one is the moisture transport. So it shows where moisture is really moving or advecting. And I want you to take a look at Oklahoma at 13Z or 9 a.m. Eastern. You see this massive surge of moisture, and as we advance forward, this moisture just overspreads the Ozarks area, the Arkansas and Missouri area. The Storm Prediction Center was monitoring this as well and put out mesoscale discussion 809 for a possible severe weather watch. When I stop on 16Z, look at the Oklahoma and Arkansas border at the plume of moisture. 16Z is 12 p.m. Eastern. Now look at these radar images. This moisture is situated right on the axis of the trough, and this axis would be the cold front. So the moisture comes into contact with the cold front and is shot upward like we talked about earlier. By 1:15 p.m., just east of Springfield, Missouri, these storm towers had gone up and were now producing half-dollar size hail and 60-mile-per-hour winds. Okay, we've talked about lift and moisture, but what about wind shear and instability? When we look at CAPE, specifically mixed layer CAPE, remember there was an outbreak going on already, so we had plenty of CAPE ranging from 2,000 to 3,000 joules per kilogram. That is just insane instability, practically double the 1,500 joules per kilogram needed for rotating supercell thunderstorms. Granted, if you take a look at the blue areas, this is the temperature inversion I mentioned earlier. So we're looking at 2 p.m. on May 15th. I'll advance this forward. So now we're looking 24 hours later at 2 p.m. on May 16th. Now in the southwestern portion of Missouri, keep in mind the radar, this is where the severe thunderstorm was taking place that we just looked at. At 2:08 p.m. Central Time, the Storm Prediction Center issued mesoscale discussion 817 for a tornado watch. This area maintained around 3,000 joules per kilogram of CAPE, which is extremely high. Looking at the wind shear at the same time, the area overspreading the region ranged from 50 to 70 knot wind shear. And anything above 40 knots of wind shear can help foster supercell growth. Another value called Storm Relative Helicity, or SRH, looks at the ability for an updraft within a thunderstorm to rotate. This rotation can foster large hail or a tornado. 150 meters squared per second squared is the threshold for potential for tornadoes, and we were over 200 meters squared per second squared by that 2 p.m. Eastern time frame. Without getting too technical, lapse rates determine how fast the temperature drops with height. This affects the energy released during storm formation and determines how strong storms can be. Lapse rates are measured from 0 to 3 kilometers up, the low level, and from 3 to 5.5 kilometers up, the mid-level. Now, typically for a tornado event, we want to see low-level lapse rates elevated. However, for this particular event, they were elevated a little bit, but they weren't really impressive. With that said, looking at the mid-level lapse rates is a different story. At 18Z, or 2 p.m. Eastern, mid-level lapse rates were hovering from 7 to 7.5 degrees Celsius, approaching 8.5 degrees Celsius in the southwestern Missouri area. And one final measure to look at is a composite measure, which looks at a bunch of ingredients, most of which we've already looked at to give a rating and a probability for a strong tornado. This is called the significant tornado parameter. Anything above 1 suggests a probability for a strong tornado. At 18Z, areas in southern Missouri were showing an STP of 5. By 5 p.m., the STP had hit a maximum of 8. So this is another way to show that this was well beyond a normal day. Already this checks all the boxes for a potentially impressive tornado outbreak, especially with the ingredients covering the areas across Missouri, Kentucky, and Arkansas. By 2:15 p.m. Eastern, the severe thunderstorm had grown to supercell status, and what makes a storm a supercell is a persistently rotating updraft. Here at 2:15 p.m. on the velocity radar product, you can start to see the evidence of some broad rotation, but nothing that screams out that the storm was tornadic. In just 15 minutes, however, that would change, and the storm would form a mesocyclone and received its first of many tornado warnings by 2:30 p.m., also destructive baseball-sized hail. The storm would continue to rotate, but not really produce. That would change right before 5 o'clock Eastern, as the storm's first tornado would touch down near Bell City in Missouri. By 5:30 p.m., the tornado warning was upgraded to a particularly dangerous situation tornado warning, or PDS. This is a rare warning that is issued for confirmed tornadoes that are expected to cause extreme damage or loss of life. This is supported by an increase in storm relative helicity to 300 meters squared per second squared. The Storm Prediction Center was watching this area and put out Mesocell Discussion 821 at 6:06 p.m. Eastern Daylight Time. In it, they stated there's potential for strong tornadoes and a long-track high-end tornado is possible. At 6:51 p.m., Mesoscale Discussion 823 was issued to discuss the issuance of a tornado watch for the central and eastern part of Kentucky. It was anticipated for the lower-level jet to strengthen with the ongoing supercell and for storm relative helicity values to continue to increase. Thus, at 7:15 p.m. Eastern Daylight Time, Tornado Watch 269 would be issued for all of central and eastern Kentucky, as well as parts of West Virginia and southern Ohio. This was a high-end watch with an 80% chance of 2 or more tornadoes and a 60% chance of a strong tornado at EF2+. So now we come to 0Z on May 17th. That's 8 o'clock Eastern. The 500 millibar jet shows the jet max over the Missouri-Illinois area, but still heightened shear around 65 to 70 knots. When we look at the 700 millibar chart, this is where things really start to get interesting. So let's see the projection of the short waves from earlier in the day. This isn't an exact science, but given where the convection was ongoing, I'm making an educated guess. So at 0Z, the supercell had an ongoing tornado in Christian and Todd counties in Kentucky with a PDS tornado warning. And I attempted to draw around where the storm was, and you can still see it's being carried by heightened wind shear. And looking at the 850 millibar moisture transport, there's just a plume of moisture available for the storm to ingest and just to keep going. This had already become a long-track supercell thunderstorm and was in the middle of producing its third tornado. Storm relative helicity was at 300 meters squared per second squared, with storm motion pretty much due east. The mid-level lapse rate had jumped to 8.5 right around where the supercell was. We're approaching the time now where the storm produced the tornado in Russell, Pulaski, and Laurel counties. So quite a few things happened here. Once the tornado lifted in Christian and Todd counties, the supercell stayed strong, but also was somewhat stable as it crossed over Warren, Barron, Metcalfe, and Adair counties. But some events took place that played in favor of the storm's mesocyclone to rapidly intensify. I have something before you called the MSL pressure and surface wind, which does what it says. It looks at the air pressure at ground level. So at 8 a.m. Eastern Time on the 16th, we have our low pressure system over Minnesota. We also have a high pressure system over the Gulf and I've included this because I thought it would be a contributing factor to the moisture advection. Anyway, watch what happens when I move this map to the 0Z map. A second low pressure system formed off of the primary low, and it formed between Wisconsin and Illinois. This sort of created its own mini trough, and with the associated axis of this trough, a shortwave. Now it's peculiar that this supercell was just ahead of this wave at this time. With the wind shear in place and the intense amount of moisture advection taking place, coupled with 3,000 joules per kilogram of CAPE and the shortwave, this was not only conducive to storm initiation, but promoting a storm that was ongoing. Also keep in mind there was absolutely nothing to the south or southwest of the storm, meaning the storm was able to ingest insane amounts of warm, moist air to help fuel that persistent updraft. But something changed once the storm was over Russell County. This is the surface map at 3Z or 11 p.m. Eastern, and at this point the tornado was in downtown Somerset. So here's a radar image where the storm was over Adair County, and a couple of things to note. First off, there's no active tornado at the time, but the storm was gaining strength at this point. In addition, there was some convection attached to the supercell at 10 o'clock Eastern. Now, let's move this forward 15 minutes, and you see that the band of storms there that was connected to the supercell have now separated. And also, new convection has formed very quickly, which tells me the boundary we just looked at was influencing the environment here. This shortwave is also evident on the 700 millibar map, and closer to the surface, here is the 850 millibar chart. And again, look at this area I have highlighted here. These shortwaves help to produce both lift and vorticity or spin in the atmosphere. Not only that, but when you look at the bulk shear map at 2Z, with 60 to 70 knots of wind shear, it was just a recipe for a significant severe weather. Winds even at the 300 millibar level were maximized near where the supercell was. There's a small area near the Kentucky and Tennessee border where 100 knots of shear was present, just south of the supercell, and we were sitting at 4 on the significant tornado parameter. Another possible factor, but I can't say with full certainty, is to look at the storm behind the main supercell. Is it possible that this storm provided a nudger? I've outlined a simple diagram of the anatomy of a supercell thunderstorm. It's important that the mesocyclone receives a supply of inflow to gain strength. While the surge of wind shear might have been an initiating mechanism for the tornado, the storm behind the main supercell would end up growing and actually become a supercell as well. With consideration of the nudger theory based on research from Cameron and Nixon, it's very possible that the outflow from this storm somehow aided this in sustaining the tornado, and perhaps even helping it to grow into the almost mile-wide monster that it would become near Mount Victory. With all these factors in mind, everything lined up just right to create this tornado. At 10:26 p.m. Eastern Daylight Time, a tornado touched down near the County Road 619, just north of County View Road, causing roof damage to barns and outbuildings. The tornado was at EF4 intensity, wind speeds under 100 miles per hour. After it went through Whittle and Ely, the tornado quickly strengthened first to EF2 strength, then to EF3 as it went through the Gosser Ridge area and into Pulaski County. Passing to the south of Nancy and barely missing the Mill Springs Battlefield, Pulaski County Park, and just missing Lee's Ford Marina, the tornado would then enter downtown Somerset around the Parker's Mill Road area. Many businesses were damaged or destroyed, including Speedway, Baxter's Coffee, the Redeemer Lutheran Church, South Kentucky RECC building, and the Adonta Group, lost 2 buildings, and the AB Studios building was completely destroyed. This is just hitting the highlights because plenty more businesses as well as homes were damaged or destroyed. As the tornado exited Somerset and entered the Daniel Boone National Forest, something happened that Pulaski County has not seen in a very long time. The tornado gained strength quickly and caused its first EF4 damage in Mount Victory. This wedge tornado plowed through the Daniel Boone Forest, completely debarking trees, and the damage was so extreme the scar can be seen from satellite imagery. There was a period of weakening, but unfortunately the tornado was not finished yet. It plowed into London with many EF4 damage indicators. It hit the Sunshine Hills subdivision and would tragically take 17 lives. Prior to this, there was 1 fatality in Russell County and 1 fatality in Pulaski County. The tornado would also hit the London Corbin Airport, causing significant damage, and it also destroyed a medevac helicopter. Just as the storm was about to exit Laurel County, the tornado weakened, and at 11:56 p.m., the tornado would lift. This tornado would be given a rating of EF4 with winds at 170 miles per hour. The tornado traveled for 60 miles and was nearly a mile wide. I feel like it's important also to mention that this one storm lasted for over 500 miles. It successfully produced tornadoes at least 4 times from Missouri to Kentucky. I've not seen a long-lived supercell like that since December 10th, 2021, with a tornado that hit Mayfield, Kentucky. There were other things I wanted to touch on, and I may do a follow-up video or a post on my WX Kevin Facebook page. But I want to wrap this up talking to the people of Russell, Pulaski, and Laurel counties. I know this event was scary. When I first was looking at the ingredients present, I was a nervous wreck. Even when I was making the initial forecast, I knew it was possible. It wasn't out of the question for Somerset to be hit by a tornado, but usually the ones we receive are weak and brief. We usually get lines of storms rather than these discrete supercells that drop wedge tornadoes. When I was monitoring things that evening and first learned a tornado was in progress, I looked at this radar image. This shows that the tornado was very close to my house. I wasn't sure if my family was going to be okay. Thankfully we were, but I very easily could have been one of the people picking up the pieces like so many people were. This was without a doubt the strongest tornado to hit Pulaski County since the April 3rd, 1974 super outbreak. We went 51 years between catastrophic tornadoes, so it's safe to call this a generational tornado. Is it possible that this occurs again in the future? I would be lying if I said no. It is very possible that this could happen again. Is it likely to occur? Not particularly. But May 16th, 2025 was an exceptional event. It's not the norm for our area, and I would like to do a video on storm anxiety in the future because I know the next storm that comes through, people around this area are going to be thinking about May 16th. I was there covering on my WX Kevin page until I couldn't any longer whenever my cell service and my internet went out. I couldn't have known that a high-end tornado was going to plow through Somerset and London and cause the damage it did in Russell, Pulaski, and Laurel counties. But I did my best to warn everyone, and I will continue to do so. I want to end this video by honoring the 19 people who lost their lives to this tragic event. 19 people who should still be here today, and 19 reasons to keep learning and improving. Richard Dickey McFall, 73. Wanda McFall, 66. June Fisher, 74. Nancy Clem, 69. Sherry Smith, 68. Darlene Miller, 67. Tiffany Heim, 48. Kenneth Elliott, 63. Lisa Fortney, 50. Marshall Miracle, 25. Bobby Tillman, 76. His wife Bernice Tillman, 73. Firefighter Major Roger Leslie Letterman, 57. This hero was a hero to the very end, as he shielded his wife from the tornado. Linda Sweet, 72. Gary Sweet, 71. Pamela Mason, 67. Deborah Edelman, 93. Ray Cowan, 88. Melody Godby, 68. If you enjoyed this video, please like and subscribe. My name's Kevin with WX Kevin. I'll see you next time.